Hello, everybody. The translators have been doing a wonderful job so far, and I'm going to really put them through their paces now. So I want to talk about GraphQL and REST in a way that's not overly hyped, and that's the way it's been talked about far too much recently. I like to use an analogy, and I really like bicycles. Someone actually asked me the other day, you've got a couple of bikes, right? Which one's the best? And I could not possibly pick which of my many bikes is the best. So, wonderful. That does nothing for the nerves. So somebody asked me which of my bikes is my favorite, and I have a couple. This is just some of them. They're all for totally different stuff. And it works as a pretty good analogy for different types of APIs, because there's a lot of bikes have been built for use cases that you probably haven't imagined. There's different styles of API. Some of them look kind of fun. Some of them you really can't work out what the use case is for at all. And some of them are obviously hacks that seem to work perfectly well. So it's very important to say that I am pro GraphQL, I'm pro REST, and I'm pro RPC. I think they all have a place. I've recommended all of them at my job at WeWork. I'm on the platform team, and we help come up with kind of API guidelines and standards and practices that help our systems talk to each other in a better way, and different services have their place in our architecture. A little part of this talk is based around the idea that GraphQL is REST 2. This really frustrates me because they're very different things. I think a lot of people don't necessarily know a lot what they're talking about REST or GraphQL, so comparing the two is very difficult for me to watch. It's just nonsense. Okay, so maybe GraphQL is at least better for APIs. And again, define better. You can't really. It's just more nonsense. A lot of the stuff about GraphQL currently, a lot of it is just really, really good marketing and a whole bunch of hype. GraphQL is very, very good, but a lot of the people kind of blogging about it are doing so with little experience. People used to do the same thing about REST when REST was considered new, and again, they were like falsely advertising its benefits, ignoring some of the cons and just saying it was amazing without really understanding it. So we're in the same position now as we were, say, 15 years ago. My main concern is not that, oh no, someone's wrong on the internet, like that happens, but the main problem is time wasting. Whenever someone convinces somebody to use a tool that isn't necessarily the correct tool for the job, they run out and redevelop the entire API, and that wastes a lot of time and money, and it's damaging. A lot of the features that people recommend, that people love about GraphQL, are completely available in REST. Like REST really doesn't really care, and so the misuse of any tool is just embarrassing. Like this is a great bike for a child, but this person shouldn't be using it. I really just want people to make educated decisions about the correct tool, so they don't waste any time. So a lot of the confusion comes from the fact that GraphQL is newer. Newer things are always better, right? They also have a really nice website. You go to this website, it explains how you do everything. There's download links, there's tutorials, there's guides. And if you look at REST, it's obviously a lot older and it's a lot nerdier. It was, I mean, this is the website. This isn't broken. This isn't a failure of the website. That's just legitimately how it looks. And yeah, sure, it's a dissertation on a networking architecture. Like, don't expect it to be a wonderful marketing page. But REST as an architectural concept is pretty much more bike analogy. REST is pretty much the concept of a personal bike, right? It's literally just the idea of a bike. And there's a whole bunch of concepts that REST has. It doesn't much care about the components you use specifically, but it does want you to really use these fundamental concepts that make REST what it is. You can swap out various components, and as long as it follows these same concepts, it's still a REST API, right? GraphQL, however, is a specific type of specific like track racing bike built by a specific company, right? It's an instance, it's an implementation of those concepts with a specific goal. Looks like one of these. It's a really nice bike. It's a $4,000 track racing bike. It's optimized completely for speed, but it's ignored quite a few important concepts. One of the facts is that it doesn't have any brakes. You're paying $4,000 for a bike with no brakes. Now, that makes perfect sense for its implementation. Like, you're racing in a velodrome, you don't want any brakes. If one of these people stops, they're all going to die. So you don't want sudden things. Like, it makes sense for them. But there are downsides to not having any brakes. It's not a perfect world. I was there for this crash. I wasn't in it, thank God. So GraphQL is optimized for network speed over everything else, right? It focuses on tight coupling between the server and the client, and it ignores HTOS, which we'll talk about more, and it ignores most of HTTP. REST is optimized instead for longevity. It doesn't really care about performance. You can make it more performant. It doesn't necessarily need to be slow, but the absolute goal of REST is not utmost speed. It mostly cares about decoupling the client and server so that when there's a problem, things can react a little bit more intelligently. So the two have totally different goals, and I want to talk about specifics, enough of the bike metaphors. One of the whole GraphQL homepage is based around false differentiation. It seems like someone that never understood REST is writing this website. They talk about get exactly what you need, right? You make a query and say, I want these 3 fields, you get those 3 fields back. That is the concept, that's how it looks, right? You post saying, I want to find out the length, width, and intelligence level of this turtle. REST allows that. REST has always allowed that. You can use a concept called sparse field sets or partials. And you just say get turtles 1, 2, 3, and you ask for the fields back. GraphQL has a type system. Again, this is just another concept, another component added in, and you specify the types. So instead of just vague JSON being returned, and you don't really know what the fields are, what type they're meant to be, things like that, you get a level of type safety with GraphQL that really helps. And again, REST allows that. It's never not allowed that. REST doesn't care if you use JSON or lolcat or anything. You can use anything. And so if you want to use JSON, which is very popular, JSON schema or JSON LD help you describe what your JSON data is. You can also use protobuf and cap and proto for a binary-based language with very strict types, so that literally if you get the contract wrong, it won't work. You can get, in GraphQL, it tries to ignore the whole networks are slow, the HTTP handshake is slow, so they just kind of bulk it all up. And again, REST allows that. It's called compound documents. And they exist in multiple forms in things like JSON API and OData. Active Model Serializer will help you with this. Again, GraphQL advertises the fact that it beats REST because it doesn't have URL versioning. REST should not have URL versioning. They advertise evolution, where basically you add strings and then deprecate them, right? If you watch the whole thing through, you've got a couple of fields, you add a few more fields. And this has been heralded as the way to go for REST APIs for 20 years. It literally begs you to do that. And Roy Fielding says, like, you should be doing this. You should not be using URL versioning for it. And that's a whole different topic in itself. So GraphQL is a query language, which is not exclusively designed for, but is usually implemented over HTTP. There's nothing particularly new about query languages. Like, they've been around for a long time. They just looked a teeny bit more silly. FQL, anyone use FQL? Yeah, like 2 people. So FQL was Facebook's kind of attempt at making SQL over HTTP, right? And the whole idea was that instead of you going to these very rigid and predefined endpoints to get kind of data structured in a certain way, you could ask for whatever the hell you wanted in whatever format. And it totally made sense. Like, I thought it was kind of cool. I never really used it. Seemed a bit odd. But for Facebook, there was a big issue. They had to write 2 lots of code for everything. There was the code that worked with FQL and the code that worked with their REST-ish API. And they wanted to design one format that worked for both of them. So they basically, they combined FQL with REST, ignoring Hypermedia entirely, and came up with GraphQL, which was for them a really good approach. Sparkle, anyone use Sparkle? It's got such a cool name, but no one used it. And you can kind of see why. Like, this is a design language, this is a query language, and so this selects humans where they're humans and they have at least 1 child or something. Like, it's a really complicated language, but it can do a whole bunch of stuff. FICL, anyone use FICL? Not really sure what it stands for, but it's another standard made by the IETF, and this will get anything with a title which has been updated in the last day or have a title ending with bar. That's a pretty advanced query for an API to make, right? But all these query languages, they kind of suck at leveraging a lot of the internet, and one thing they really do suck at is caching. So client caching in GraphQL is entirely, the client is responsible for everything. They have to either find out or guess how long they should hold data for, and then try and work out how to invalidate that themselves. The problem when you have a client figuring this stuff out is that if you have two clients and they figure it out differently, you have different data on different apps. You'll see a foo and a bar on two different screens, and that just confuses people. So REST basically says this should be a concern of the server. The client, the cache controls should be defined on the endpoints themselves, so the clients can just follow the rules the server sets, invalidate the data, and get new data as appropriate. And there's loads of tools in HTTP that you can use to do this. And when you implement these cache control headers, not only can the clients, like your iOS app knows how to cache it, and then another iOS has another cache separately, but you can implement network caching that all the clients talk to that hold their own cache and completely short-circuit the server. There's loads of tools and services to do this, including Nginx itself. You don't have to get too fancy. But basically, yeah, if it hits the cache, it just hits your server, it hits your cache server, and your app server is just chilling. It's not doing anything. And then, of course, if it misses, it goes and gets data. So, back to Turtles. Client A is making a request. They've chosen to use fields, which is client A wants the name and the lifespan, right? It takes 200 milliseconds to respond. Client B doesn't really care about the lifespan and just wants the name. They think that asking for less data will make it quicker, and it is. We've saved 8 milliseconds. Hooray. Problem is, this is only a 4% speed up by missing the cache, and we've made our application server do more work than it necessarily needed to. So in another world that doesn't have fields or chooses not to use fields, it might take a little bit longer because there's more data coming back, right? You've got more than the fields that you want, and you're not necessarily using them. But the second time someone calls that same endpoint, it's going to be drastically quicker because your application server wasn't involved at all. This means there's a 10% slowdown initially, and you got 46% faster overall by using caching and having too much data come back. So it's very much a misnomer when people say, oh, you get more data and it's slow. It's not true. You can also enable caching in your applications by using really awesome tools like the HTTP cache middleware, which is amazing. You just plug it in, and then any request you make just like magically caches itself. And if Faraday recognizes another request coming in which matches those rules, it just doesn't bother making it and returns the cache. It's brilliant. I made a bit of a compromise. I wrote an article. All these slides will be online with all the links. And you can basically use partials. So you still get some cache hits as long as people are asking for the same groups of fields, but you still have some customization to reduce the amount of data coming back. GraphQL cannot use those existing tools I talked about, Varnish, Squid. It can't use them because, oh, that's a typo. Oh, well. And one of the other major issues with GraphQL is that basically all the data in your database has to be readily available for any potential query, anything. Not just the fields that you've defined as indexes, not just the things that you think are appropriate to include, but pretty much anything. Like the clients can just have their way with your database, and that makes it really slow. You need to restructure your entire data set, and GitHub and Facebook and everyone else, they've totally done that. They've got services and whole teams of people working on making all of their data readily available, but like most of us don't have that. This is not just an issue for GraphQL. This is an issue for making your API highly customizable. The more you customize it, the harder it is to optimize for the incoming queries. And these things happen. Put your hands up, XY people. Yeah. So Sebastian, Nicolas, and Juan Pablo remember this. We had problems where we were using JSON API, and people were trying to reduce the number of HTTP queries. And so we'd have like 10-second mega queries where people were just downloading all of the data. And I joked and said, like, we should just make we should just make a publicly available, like, you can curl down an SQL file and just run it locally, because it would be quicker than making the API do this crazy query. And this is a problem for GraphQL and JSON API. So multiple handshakes are usually not going to be your bottleneck. They're advertised as this terrible, awful thing, but that's not really the case. Like usually making specific targeted endpoints that are well cached and well defined and do a specific thing, and you request all those things in parallel, or in asynchronously, sorry, is usually quicker. And HTTP 2 solves that problem of the handshake being a problem anyway. You can just use HTTP 2, it's available. So Part of the comparison between GraphQL and REST is usually a problem because people are always talking about REST-ish APIs, and I really hate being that guy, oh, that's not RESTful, but it's really hard to make a comparison between two things when you don't know what one of the things is. Most REST-ish APIs miss one of the most important concepts of REST itself, and can you see what that is? It's a lack of controls. When you miss the hypermedia, yeah, like it's technically a bike, but it's like not the best. So this richness and maturity model, you have various different levels, and down here they're kind of talking bad about RPC, which is a little bit silly. They're calling it a swamp. But then you move up to resources, you get up to HTTP verbs, and while you're down here, you still only have a REST-ish API. All of these things are REST-ish. They've got some of the ideas, but they've kind of stopped there. And that's okay. I've built REST-ish APIs in the past. But the level they're missing is hypermedia controls. And when you get here, you're at the glory of REST, theoretically. A little bit hyperbolic, but okay. Not REST, REST. So hypermedia controls are usually seen as confusing or slow, and therefore people ignore them. And because people ignore them, people don't talk about how useful they can be, and therefore people ignore them. This is what leads to people thinking that things like GraphQL are a legitimate replacement for REST, because they're not using the thing that makes something RESTful, therefore they don't understand what they're talking about. I've only recently kind of got into the world of understanding hypermedia, and it's pretty handy. But yeah, they're really misunderstood, and it mostly comes from people thinking that REST is just CRUD. If you think that REST is just CRUD, you just add in stuff, deleting stuff, modifying stuff, then that makes sense. And if you think that hypermedia links are just for related data, of course it makes you angry that you have to wait for a response before you get to find out, like, oh, I can now go and get this second thing. Like, you know where the URL is for that second thing, so why would you wait? That's really not what the hypermedia links are for. They're not meant to be a static list of available related resources, because everyone already knows what those things are. Instead, REST and hypermedia are more like a state machine. The S is for is what explains this. State transfer, sorry, words. So who's worked with state machines in the past? AASM, event machine, yeah. I like Statesman because it's really simple. It doesn't do a whole bunch of other stuff, but basically you define your states and you define transitions between them. The idea is that you can still fire actions, but they are kind of an afterthought of data changing in a certain way. So you try to change the status, and then if that works, you can then fire an email. So instead of having an RPC style endpoint where you're like, send email or send invoice, you just kind of off the data and it happens as an afterthought. So once you understand the idea of state machines, you're starting to understand Hateos. Hateos is Hateos is hypermedia, same thing. Hypermedia controls are just a state machine exposed in your data. So if this link is here to pay an invoice, that means that you can pay the invoice. If that link isn't there, this isn't a payable invoice. That's so simple, right? Why don't we all do this? The problem is, what a lot of people do is they'll put things in here like, is paid and various other fields, and then clients have to work out, based on the fields that they see coming back, if they should be able to pay this invoice. And the problem there is that, once again, if you have two different clients working out things and they think they're getting it right, they might actually be getting it wrong. And even if they're getting it right at the time, if you change your fields around a little bit, then that could affect the assumptions that they're making about the state. So you just give them the state. You tell them what the current status is, and you tell them what they can do next. And that's the whole point of a REST API. This stuff is really useful. Think of it as like normalizing your actions. Instead of having them spread around, you're bringing them up one level into the server, right? This is really useful. But the downside is that when I see this link, I don't know what to do with it. This is kind of the way that people have always recommended hypermedia back in the day. And it's kind of, think of it as level 1 hypermedia. There's different levels of Hateos. So yeah, one of them is just a string. You just got a URL, and all that you know is that you can click it, but you don't know what you're doing with that. You don't know, with no part of hypermedia guarantees that this thing will work. They just let you know what you can try. But you can make this URL, so this thing should respond to a options query, and then you can provide get and patch to show that you can get this thing, or you can modify this thing. But that's still pretty vague. That doesn't tell me like specifically what I can update, right? So you can use level 2 hypermedia for this, and the idea is that you can use JSON schema or something similar to detail what the fields are. JSON hyperschema is being worked on to show you what other available actions are around, but that's still kind of in the works. But the idea is that adding this JSON schema and these other bits of metadata to that options request means that people can see what fields they should supply with that action that they're going to make. Trouble is, this is entirely optional, and it's pretty much hidden. This is actually a benefit and a con. It's a pro and a con, because in SOAP, you like had to do this stuff. You had to use the WSDL to make sure that your stuff conformed, and people hated that. So people liked REST because it didn't have this stuff, and now we're building this stuff into REST, and people are complaining about it. It's funny. But making it optional is really good, because if people want to be ignorant and build weak, flaky clients, they can do that, and you can charge them money for using your API, and their stuff might break, and that's their fault. But you can also use JSON schema if you know what it is and if you want to use it. But the third level of Hypermedia is to put those available actions in the payload. This brings it much closer to what REST was intended for, which is literally a browser for a machine. Instead of making websites for humans with HTML and CSS, you're making websites for machines with JSON, and people just put their own CSS on top of that, right? So the idea is, in your actual response, up here we'll have all the fields and all the data and everything else, and then down here we'll have this expanded actions section that says, like, okay, you've got a name for the action, human readable thing, we're going to post it to this URL, and we're going to send these fields, and here's some validation for it. This is one example of Siren. There's loads of other systems. But the idea is that you can actually build dynamic, I'll get to that in a second, but the downside of this, obviously, is that it increases the size of the payload. Whilst GraphQL is trying to make their payload smaller, we're actually making it bigger, and maybe we can use gzip or something to help with that. But one of the benefits is you can use all these actions to dynamically create UI. And this doesn't need to be in the same API. These links can go to some other totally different service, and you can still, like, the client doesn't have to do anything to make those options available. They're just shoved into their system, which is awesome. It means that the mobile client and the web client will have the exact same options available, and if I can click a button here, I can click a button on the mobile app. And I've run into that problem before, where I can do something over here, but I can't do it over there. So, still pitching Hypermedia. GraphQL can't help you with other systems. You are just talking to that API, and you're getting data from it and sending data back, and that's it, which is maybe fine. But Hypermedia totally does that. You can have an Xbox app that has the exact same state as everything else. It cannot mismatch. But okay, you don't want Hypermedia. I haven't convinced you. Moving on. I think GraphQL is an amazing replacement for REST-ish APIs, right? If you don't want to know how to do all the things that make a really good REST-ish API, and you definitely don't care about Hypermedia, GraphQL is probably what you should be using. The fact that it's in one package and brings everything together really helps you. It also makes deprecations really awesome. So evolution, whilst not being unique to GraphQL, is much easier because every single client has to. They literally have to define all of their fields. We know if you're using a thing. Formatting, come on. But next on the type, you just put deprecated next to the field, and when a deprecated field is called, you know that it's being called. HTTP APIs, endpoint-based APIs, can use the sunset header to mark the entire endpoint as deprecated. This is very new. You should look into it. I've created a Faraday sunset middleware. You just plug it into Faraday, and if you're using a deprecated endpoint, it'll freak out. Put something in the logs, put something in active support if it's there, and it will look something like that. It'll be like, oh, this thing's going away. Or if it's in the past, it'll freak out even more and say, seriously, this could go away at any time. But if you don't want to learn how to serialize data, how to implement sparse field sets, how to gzip your content, how to use data structures and JSON schema and protobuf and evolution, if you don't want to learn all of those concepts, which is probably most of you, then literally just using GraphQL is better, probably for that use case, right? Like you're using a subset that has been focused on this one task, and you're missing out on Hateos, but maybe that's okay for you. It's packaged in one system, which makes it really easy. You go to their website, you read the tutorials, you buy the whatever videos package, and everything just makes sense, right? But are you okay with letting go of all of the stuff that comes with HTTP, all of the networking caching, debug proxies, all of the stuff that comes with it? You should also ask yourself, how different are your clients from each other? If you have like pretty much the same app in different forms, then why would you need to have such a customizable API, right? If most of your data requests are the same, just use REST and then you can cache it more heavily. Do you trust your clients to handle the caching perfectly by themselves without any hints from the server? That's a really big ask. You have to get that right. Also, if you change rules on caching and you have old iOS versions out there, then they're still caching the data for too long, and that's a problem. I said the wrong thing. Oh, no, I just got the same one twice. Cool, moving on. And you definitely never, ever, ever want HTOS. We've been ignoring it for generations, and we should probably stop ignoring it. But if you use GraphQL, you definitely cannot have it. I would use GraphQL for a highly queryable API that had really similar, that had a wide array of clients. But I would also only use it if the data was inexpensive to query. So if we shuffled all the data into a format that could be easily requestable, that's when it's appropriate. It's great for mostly read-only like statistics APIs, right? If you have loads of analytics and things like that, people can pull them out and make their own graphs and do whatever they want. That would be a great example. If it's entirely CRUD and you didn't need to use file uploads, you can't really handle file uploads in GraphQL. You can't send it a file or download a file. You can just send data fields backwards and forwards, right? So if you need file uploads, definitely can use GraphQL. If that's not a thing, go for it. And if I was worried that the team was unable to use enough of the best practices to make a good REST-ish API, I would totally just shove some GraphQL in there so that at least they're following that set of rules, right? And on that note, I think I'm just about on time. And if you want to talk to me or have any questions, I'm around. If you like this API content, go to blog, apisuwon'thate.com, and I talk about APIs all the time. So thank you very much.